Marvelous magnets.
Hi scientists, Miss Staley here, and I'm super excited today because I'm going to be exploring one of my favorite things with you today, magnets. So if you're learning from home, you may need to look around the house and see if you can find any magnets. If you're learning at school, your teacher will organize the materials for you. We're going to be doing a series of investigations today. You may not do them in the same order as me, but that's okay. Ready to get started?
Investigation number 1, floating magnets.
Welcome back, scientists. Ready for some more investigations with magnets? Today we're going to be doing an investigation called floating magnets. So we're going to need the following materials. The magnet stand, and we're going to use 4 of the ring magnets. And of course, we're going to need our recording sheet. So today we are working on the learning goal that I can investigate and describe how materials are attracted to magnets, and I can investigate and describe how magnets can attract and repel other magnets. So the first step, and I'm just following along with the directions on my recording sheet, is place the ring magnet stand in the center of a desk or a table. I'm going to put mine here so that you can see it. Stack the ring magnets red side up. So I'm just going to put the magnets on there, like so. Now, if you take a look, you can see that there's actually some space between the base and this blue side of the magnet. I wonder what that's about. Now the next step says, when you flip over the top magnet, what happens? And why do you think that happens? So I'm going to take the top magnet off and flip it over so that the red side is down. What do you think is going to happen? Now take a look at that. As you can see, this magnet, the top magnet, appears to be floating. How do you think that is happening? Now the next piece is a challenge. It asks, can you make all of the magnets float? Using colored pencils or labeled sides R for red and B for blue, draw a diagram of your solution. Add arrows and words to show your thinking when necessary. Be prepared to share how and why your pattern works. Let's see if you can get it done.
Investigation number 2, magnetic or not.
The purpose of this investigation is to find out if an object is magnetic or not. So as you can see on our data chart, we've got 2 columns. One is magnetic, one is non-magnetic. You're going to take your magnet and test a variety of objects to see which are magnetic and which are not.
Test other objects and fill out your chart. Investigation number 3, attraction or repulsion.
In our next investigation, we will be looking at how magnets interact with each other. So you're going to have 2 magnets, and if you notice on the data chart, the poles are labeled. So this is an S for South Pole and for North Pole. These pictures are going to show you how to set up your magnets. Before you do your investigation, though, you're going to make some predictions. Will the magnets attract or repel? So I'm going to give you a second to make your predictions, and then we'll get started. In the first image on the table, the magnets are set up so that the south poles are both on the left side. So I've done that for you. Now let's see what happens if I push the magnets together. What do you think? Notice that the magnets attract to each other. The North Pole was attracted to the South Pole. Now we've got both of the North Poles closest to each other. What do you think will happen this time? Did you see that? When I put the 2 North Poles together, the magnet appears to be pushing it out of the way without even touching it. Now we've got both North Poles on the left side. What do you think will happen this time? Once again, the North Pole was attracted to the South Pole. Now we have the 2 South Poles closest to each other. I bet you know exactly what's going to happen. Once again, the two poles are not attracted to each other. They repel each other or push away from each other.
Investigation number 4, a magnet's strongest points.
So for this investigation, I have my bar magnet that's labeled N for north and S for south, and I've got some paper clips, and of course, I've got my recording sheet. So what we're trying to do, remember, is to find out what is the strongest point of a magnet. So I've made my prediction on the number of clips that the South Pole end will hold, and now we're going to test it out. So I've got my South Pole, there's the end, and I'm just going to start putting magnets on. And my goal is to see how many magnets I can get to stick to the, or how many paper clips, excuse me, I can get to stick to the end. So right now I'm at 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 2 there, I have to be careful. Oh, they're stuck together. Let's see if we can get them both. There's 11, 12, oh boy, 13, 14, ooh, it's getting close, 15. So I was able to get 15 paper clips before the magnet released, or the paper clips fell off the magnet. Now let's try the center. So remember the center of our magnets here, I'm gonna stay on the red side because that's the north side. And I'm just going to put a paper clip here, and look at that. Not even one paper clip stuck to the middle of the North Pole. Now you're going to repeat this with the South Pole and end and the South Pole center. What do you think will happen?
Investigation number 5, magnetism.
So in just a moment, you're going to see a bowl of water with paper clips in it. And we're going to try to see if the magnet will attract the paper clips through the water. Before you do that though, you're going to put a prediction. What do you think? Will the magnet be able to attract the paper clips through the water? Then we're going to take the magnet and put it on the outside of the bowl. And we're trying to see, will the paper clips move without the magnet touching the water? So make a prediction on both of those and we will get started shortly. So as you can see, I've got a cup of water. I didn't have a bowl, so I just used a cup. That's okay. And inside I've got some paper clips. So what do you think? Do you think that the paper clips will attract to the magnet when I put it in the water? Got my magnet here. Let's test your prediction. And I'm just going to put it in. And look at that. All of the paper clips were attracted to the magnet, even through the water. Now for the second part, we're going to take the magnet and put it on the outside of the cup to see if we can move the paper clips without touching the water. What do you think will happen? Well, let's see. So I've got my magnet and I'm gonna just put it along the side. And I don't know if you can see, but look at that. I'm able to move the paper clips without even touching the water. And you saw those 2 paper clips jumped on and got attracted to the magnet without even being touched. Finally, you're going to test different materials to see if magnetic force can work through them. So we're going to have paper, cardboard, Kleenex, and a piece of cloth. And we're going to test each material to see if the magnet attracts the paper clips. Let's start with paper first. So I've got a piece of paper and I'm going to put it over the paper clips and let's see if the magnetic force can attract the paper clips through the paper. That didn't take long to find out. Next, let's test the cardboard. So I've got my paper clips down there, put the piece of cardboard over it, put my magnet over it. Now